Hi, in this video I'm going to build a simple Godot Engine project. It's the kind of thing I might do on the first or second day of my game programming class that I teach, but since my courses have all been put online and asynchronous, I'm going to have to make do with YouTube. After launching Godot Engine, I can click on New Project, and I'm going to name this Ball Drop. And I like to put all this stuff in my Projects folder. I'll make a folder in here called Ball Drop. And following the pattern that I mentioned in a previous video, I'm going to make a nested folder in here called Project, in which I'll actually put the project itself. I'll choose OpenGL ES2 because I'll probably end up putting this on the web, and it'll be a 2D project. Great. So what I'd like to start with is just making a simple ball that falls using the physics engine that's built into Godot. To get started with that, let's just go ahead and create a new root node. There's multiple ways to start this, by the way. I could start with the main scene, I could start with the ball itself, and I'm going to choose to start with the ball. I could click on 2D scene and then change the type of that node, or I could just use the fact that I know ahead of time this has got to be a rigid body node. How do I know that? Well, reading the documentation, really, right? I'm kind of expecting you've done a little bit of legwork here, but I'll walk you through the steps in any case. So let me show you the slightly less efficient way, because it's a common thing to click. So because we're making a 2D ball, we might say a 2D scene, and this gives us a node 2D as the root. And node 2D is kind of a catch-all, right? It's a superclass of many specific classes of 2D nodes. I can right-click on this and change its type to RigidBody2D, which you can see the little tip right here that tells us, yeah, this is going to be controlled by the 2D physics engine. If it was something I was controlling myself, I'd probably make it a kinematic body 2D. Right away, we get this handy warning here that tells us we need to have a collision shape. So let's go ahead and add that as a child here. Collision shape 2D. And we get another warning that tells us that the shape actually needs a shape. A little bit strange the first time you see it, but collision shape 2D tells us we're dealing with collisions, but it doesn't actually specify the shape. For that, we have to go over to the inspector and set this to be, for example, a circle. This does something pretty interesting where we can come in, I'm using the mouse wheel to scroll in, and I'm using the right mouse button down to pan. We can modify the radius just by clicking on that little handle there, so that's pretty neat. I'll make it kind of large to get started with. I'm going to use Control S to save this scene, and it prompts me to, of course, save it to a file. Again, following the approach I showed in a previous video, I'm going to make a folder inside here called Source so that I can have separate directory trees for my source code and for my assets. And instead of just calling this node 2D, I'm going to call it ball. In fact, I like to also make sure this node follows the name of the scene. Okay, Control S to save. Now, if I try to run this scene, we won't see anything. I can do that with F6, which runs the current scene, or by clicking this button here. And we don't see a thing because this ball doesn't actually render itself. There's a sense in which it exists, but we can't see it. So let me show you a convenient technique when you're doing some kind of quick prototyping, and that is to just let this ball draw itself. So I'm going to go to the root of this tree and add a script. And the default path and name are fine. So from here, notice that the default template includes a bunch of commented out areas just to give you a sense of what you're dealing with. But I'm just going to get rid of those for now, because the method I really want here is called draw. So I'm going to override draw so that this ball draws itself. So I'm going to use the draw circle method, which is built in. Now I have to give it 3 arguments, and the first one is the position. Now keep in mind that Godot is a tree of nodes, right? Every scene is a tree of nodes, and each node can have its own translation. So from this ball's point of view, it is always at the origin, even though when it's instantiated in another scene, it might have a different transform, and we'll see that in a few minutes. To make a long story short, we can go ahead and say vector2 0, 0 to say this is the origin. It turns out there's a convenient constant we can use here as well. All right, the radius I'll use here, I could put in a literal value, but what I'd really like to do is use the fact that in the editor, by the way, F1 and F3 will hop between these two screens. Here I've set the radius using the control, Let's actually use that in the script. So I can do that by saying, look at the collision shape 2D child node, grab its shape, and notice the auto-completion knows that collision shape 2D has a child called shape. But at that point, the autocomplete doesn't really know what to do anymore because it doesn't know if my shape is a rectangle or a circle or something else. But I know because it's a circle that it has a property called radius. Finally, we can just choose a nice color for it. And that's all there is to that script. Control S to save. Let's go ahead and run it again. Great. So we have this ball that starts in the origin, which is in the upper left, and falls because of gravity. And we didn't have to do any other work there, right? By default, when we have a rigid body, gravity will act on it. That's great. Let's go ahead and put that ball into another scene. So the way I like to do this is I'll go to my source folder and right-click and say I want to make a new scene. I'll just call this my level. So now switch over to the 2D view. And let's go ahead and do a Control S. Oh, right, I can't save it until I have a root node. It'll just be a 2D scene. Now I can save this, and it's saved as level.tscn. Up here, I will rename that to match the name of the file. So if I wanted to put one of my ball scenes inside of my level scene, easy way to do that is simply grab the scene here, drag it up here, it becomes a child of level, and by default it has the transformation at 0, 0. It hasn't moved at all, but it's very easy to simply move that somewhere else. So I'll just click and drag, and now it starts, yeah, let's put it kind of in the top middle of the screen. That'll be good. All right, let's run this scene. Great. So running the level will instantiate the ball that we put into the scene, and of course then the ball continues to act just like it did in its own scene. So that's pretty good. That's a nice bit of work, and if you've never done anything like this before, that's a good solid step. So this is a point where I would like to make a commit to my repository, because those of you who follow my channel know that I always like to work with version control underneath me in case something goes awry. So let's get into that ball drop folder, and let's make a Git repository here. Maybe before I do that, I'll give myself a reasonable default on a git ignore file. I'll use a little bit of shell magic here. All I really want in there right now is to make sure that this .import directory that's in the project folder is not tracked, because that contains files that we don't need to put in version control. All right, git init will create the empty repository. Git status will tell us what we're currently dealing with. Let's go ahead and do git add -A to add all the files. Git status again will show us all these files that will be added. I think all those files that are staged looked pretty good, so let's go ahead and make a commit. Great. Very nice. Okay, so a lot of interesting stuff we could do from here. I think one thing I'd like to do is start bringing in some third-party assets. I'll bring in some images to replace the manually drawn stuff. I've been inspired by some of the free resources that are made by Kenney, so I'm going to go ahead and bring some of those in. In fact, I think I have them, let's see, just over here. Yeah. So this comes out of the physics pack download, and I'll give you a link in the video description. I'm going to grab one of these aliens. I'm rather fond of this green guy, so let's bring him into the game. Although maybe before we do that, we should have a place for him. Well, let's hear, one step at a time. We'll just drag that in right now. Let him be wherever he is. But I'm going to make a separate folder here now called Assets, and I'll put that image into the Assets folder. As I've said before, there are some best practices documents you can find online, and I'll add a link in the description to some of those. This is a nice idea, separating the source code from the assets. This is my experience from having done some Godot projects. Okay, so let's go back to that ball scene. Now, instead of this just having the collision shape 2D, let's also give it a sprite. A 2D sprite, great. Now, what should my sprite's texture be? I should be able to grab that alien green round and drop him in there, and there he is. I don't want the sprite to be a child of the collision, but of the root node. Let me just drag that over. And now, let me edit that collision box to match pretty much the shape of the sprite. I happened to get them pretty close originally, but that was purely by chance. Okay, so I'll save this scene. Let's go back to the level. Notice that the ball that has been instantiated is already updated to match the one that we just changed. So you can see here part of the value of separating a scene into its constituent scenes. If you do this in a way that's informed by good dependency management, then you should be able to change any of the instantiated scenes without having anything break in the scenes that use them. Let's go ahead and run it and make sure it still looks okay. Looks good. I think that that ball needs something to fall onto, so let's go ahead and make a ground for it. There's multiple ways we could do this. One thing we could do is make another rigid body that is not affected by gravity, which then the collision shape of this ball will run into. But I think what I want to do is make a tile map instead, and I'll add that directly as a child of the level. Good. So the tile map needs a tile set to be useful at all. I'm going to make a real simple one here. So let me click on here and say I'm making a new tile set. Then I can click here again to edit that tile set. Now let me get back to that physics asset pack. Let's get some wood elements, and here's just a nice wooden square. I'll bring that into my assets folder. Great. And now I can bring it into my tile set. I want to make a new single tile, so I'll click this button, give myself a little bit more room. And if I show the grid, we can see that the grid does not align with the shape of this tile. But once I click here, I can change some of the options. The size of this tile happens to be, I believe, 140 by 140. Oops, that's not quite right. Let me check the size of this tile. "70 by 70. So again, I'll just change this, 70 by 70. Click down here. Great, and that all matches up. So now, it's not much of a tile set, right? Only one tile, but the same principle would apply if I had multiple images. But to keep it simple, I'm just going to deal with this one. Okay, let's go back to the tile map. We could do that by clicking here or using the back arrow there. They'll both get you to the same place. Now, these tiles also don't line up with the size of the image that I have, but I can fix that pretty easily. Let me go over here, choose Cell, and change the size from 6464 to 70 by 70. Great. Now I can grab this tile and paint with it across my screen. And of course, this is the general approach you would use if you're making any kind of a platforming game. All right, let's run it. There goes our happy green guy right through the floor. Now the reason that happened is that although we brought in those images, we never set any collision data on them. Just like we had to set the collision data on our rigid body, we have to set collision on these tiles as well. So let's go back to the tile set, choose our tile, select it here, and notice there's a tab here called Collision. I'm going to click on that and draw a new collision rectangle around this one. And it's very simple because it'll just follow the whole thing. So I just clicked and dragged over it. We can see it gets highlighted in this sort of aqua color to show that that's the bounds of the collision box. And that should be enough that if we just run the game again, he falls right on there. Great. This seems like another good place to commit our work. Let me make sure everything is saved with a Control-S. Git status will show us that right now our assets folder is not yet tracked. So again, we'll use git add -A. Git status has a little sanity check. Notice that for each of these PNG images we're bringing in, there's also a .import file. That's good. We need those because those contain the import metadata. Sometimes you need to fiddle with that. That's not the same as the .import directory that we're intentionally excluding. If you want to see that directory, let's drop into the project for a moment. ls-A. This is the folder that we're actually excluding from version control. You could poke around in there if you wanted to, but as you can see, it's just sort of a bunch of engine data that we don't actually have to track. Okay, let's make sure we're where we want to be. And now we can say we added a graphical sprite and tiled ground. Perfect. I realize now, though, that there's actually a slight problem here, which is our script that's on the ball is still trying to draw the ball, even though it's also drawn by the sprite. That's kind of a waste of time, so let's go back to the ball and fix that up. A simple fix. It turns out, because I haven't pushed anything, I could actually amend that previous commit. So if you've never seen that before, I can show you how that works. This is the same message as I had before, and that's what I want, so I'll go ahead and save that. And there we go. So without adding a new commit, we just edited the previous commit to include that change. Now you could say, well, why not just remove that script entirely? Well, I don't want to do that because I actually want to do something in that script now. I would like to make this ball react to some kind of keyboard input so that when I press a key, some force will be applied to it. This is a common thing if you wanted to make a game like Angry Birds, right, where you're launching a projectile across the screen. And it's the kind of thing you're probably mostly concerned about if you're in my game programming class. So let's see how we can do that. Let's start by just making sure we can listen to some keyboard input. I'm going to go to the project settings and add something to the input map. Let's add an action called launch. Here it is, and we'll add a key to it, which will be spacebar. Perfect. Spacebar is easy for you to hear through my microphone. Okay, now let's make sure that this ball listens for that event. The way I'd like to do this is by overriding the process function. Process runs on every tick of the game engine, typically 60 per second. What I want to know is, on this update, did the user just press the spacebar? Or more specifically, did they just initiate the action that's a launch? Because later I might change it to something else besides spacebar. This is action just pressed is exactly what we need. Notice that the input that I specified in the input map shows right up here. Okay, so if that's the case, well, let's just start by doing something simple like printing out some debugging information. I'm doing this in part to show you that if you're not quite sure if all your pieces are working together, you can take this kind of old-fashioned debugging approach. Let's try it. Great, hopefully you see that in the output. Now, instead of printing yes, let's actually apply some physics to this object. Apply impulse is built into the physics engine. We have to tell it in which direction and with how much force we want to apply an impulse. For now, let's just kind of shoot it off to the right. The offset is how far from the origin is this force coming in, but we'll just use the origin for that, which is to say nothing. And the impulse, well, let's just pick a value we hope is good. Great, let's try it. Pretty nice. Now, unfortunately, I got my y-axis mixed up, so it shot down instead of up, but I should be able to fix that simply by inverting my y. Great. That might even be a little high, but let's look at another cool feature of Godot that we can use here. Let's define a variable that gets exported, and we'll call it strength. Now, instead of just going at a constant vector here, let's actually figure out a direction. Now that vector, of course, is pointing to the upper right, but what I really want to do is normalize this, which means make it have a unit length, make it have a length of exactly 1. But of course I need this to be vector 2 and not the three-dimensional vector. The reason I want to do that is that now I can scale a unit length vector, a vector of length 1, to any size that I want, such as that strength. Let me give this a default value up here. Now we can say that the velocity we want to add will be that normalized direction times the strength. And then of course we can change this to that velocity. Well, I'm using the word velocity there in a bit of an ad hoc way. It's not exactly velocity because we don't know the mass of the thing that we're applying the force to. Let's just leave it for now. Let's try running it. That's pretty good. Let's go back to the level. We can see now that the ball exposes this strength. Instead of having this start up here and fall, let's put it kind of right on the ground there. And if I launch it, that looks great. Maybe it has a little bit too much force on it. So we can drop that here. Now notice that doesn't of course change the ball scene. It just changes this instance of the ball. And in fact, if I reset it, it goes back to the 500. But just to show you, let's take a look. Run the game and launch. Nice. Now we might want to go in there and increase the gravity, for example, or change the scale so that it's a little bit more dynamic and visceral. But I hope that's enough for you to get started. Some next steps you might add are obstacles to run into, or targets, or, of course, changing the look and feel, adding sound effects. Your imagination is the only limit. But of course, you might have to check the documentation. Happy programming!